we need to discuss the response time. What is the response time? The response time is the time taken by the application to respond to users' requests. It's measured in seconds or milliseconds. In JMeter, for example, it is measured in milliseconds. And of course, the second includes 1000 milliseconds. Every application should have a goal to minimize the response time as much as possible. But we have more than one type of response time. First, we have the absolute response time. The absolute response time is the total time from the instant that the user clicks on a link until the response from the server is rendered completely. So we can consider it as a total response time, for example. In some cases, we need to know the components of the absolute time, the absolute response time. For example, you have a large amount of absolute response time for your application, 5 seconds or 7 seconds. You need to divide it into more than one component in order to know the root cause of the bad performance of your application. We have also the perceived response time. This is the response time as perceived by the user. What does this mean? For example, you might have a complex web page that has a response time which is very high, okay? It is unacceptably high. In this case, the performance engineers might structure the request and the response into a set of requests and responses, and those could be rendered progressively. So part of the response is received, the user is dealing with it, and the rest of the response is still processing. So in this case, the response time, the absolute response time might be, for example, 10 seconds, but the perceived response time, what the user sees is 1 second, okay? He can interact with the server after 1 second. But the reality is that the server is not ready yet, okay? It is not 100% ready. Perceived response time is very important because this is what gives us reputation to our customers, okay? If they find good perceived response time, even if the absolute response time is bad, they will keep using the application and they will like it. Then we have the rendering time. The rendering time is the time taken by the browser to parse and render the response received from the server. This depends on the complexity of the web page, also the presence of multimedia, presence of JavaScript, and whether the browser needs to generate some content. So you might have many pages inside your website. When you send the GET request to all those pages at the same time, you find some pages loading quickly and some pages are loading more slowly. Why? Because the page that's loading slowly has a big amount of rendering that will require more time. In this case, for example, we might compress the images, search for CSS components that take a lot of time to load and so on. Then we have the network latency. This is the time taken by a data packet to be captured, transmitted, and processed through multiple devices, then received at its destination. The network latency doesn't include the server processing time or the rendering time. And of course, it varies depending on the location of the user, time of the day, and the network load. So for example, you might have a good server, but there is a problem in your internet connection. In this case, the total transaction time might be large. The transaction is the request and the response. But the response time is not large. So why is the transaction taking long time? Because we have network latency on the client side, not the server side. Network latency, of course, varies depending on the application. For example, if we are talking about online gaming, anything that is less than 100 milliseconds is acceptable. If you play a shooting game like Call of Duty or Battlefield, if you play football, okay, or soccer like FIFA, anything less than 100 milliseconds is acceptable, but the range from 20 milliseconds to 40 milliseconds is considered optimal. So what does this mean? What does the word of network latency 100 milliseconds mean? This means that, for example, I am playing an online game, I am shooting the ball, or for example, I am shooting or I am moving. So the time between my movement that I did using the joystick and the moment that this movement appears on the game, okay, so other players can see it, is 100 milliseconds, which is 1 out of 10th of a second. Of course, if the network latency is less than this amount, this would be better. But like we said, It depends on the servers, where are they hosted, and also on your internet connection. So for example, when I play online games, some games have a ping, which is a latency of 100 milliseconds, and other games have a latency of 50 milliseconds. Why? Because one game that I play, its servers are hosted here in Africa, because I'm in Egypt, and the other games have their servers hosted in Europe. So in this case, the network latency is different, okay? Also, I have two networks in my company. So when I connect to the first network, I have a network latency of 40 or 30. The second network has around 300 or 400, which is impossible to play online gaming using. So there are many factors that create the amount of network latency. Then we have throughput. So what is throughput? Throughput is the number of transactions per unit time. So for example, we have a registration form. How many users can register to this form in a minute or in a second? Okay, so if I perform a huge load on the system, I can measure the throughput. So my system is able to perform 60 transactions per minute, for example. So the throughput is 60 transactions per minute or 1 transaction per second. The throughput is measured in transactions per second or in bandwidth, bytes per second. How many bytes are sent per second? In JMeter, for example, it is measured as transactions per second. But you have to understand an important point here. For example, in JMeter, if I create 10 requests and send them in 1 minute. So here you will find that JMeter is telling you that the throughput is 10 requests per minute. This doesn't mean that this is the maximum throughput, okay? Because I am not applying load on the system. This is the throughput that is happening now. The maximum throughput, after this we have utilization. Utilization is the ratio of the throughput to maximum capacity. So for example, today, how many transactions are happening per hour? On the other hand, let's say 900 transactions. But what is the maximum number of transactions that can be applied per hour? It might be 1000. So here 800 divided by 1000 is 80%. This is our utilization. It is not desirable to operate above 80% utilization, okay? So 70% is good, 50% is good. If we have more than 80%, we might divide the load onto more than one server using load balancing, for example. Then we have robustness. So robustness is how well the application detects and handles various errors and exceptions. What does this mean? You might perform spike testing on the server. So in this case, the server is not useful and it is not responding. Okay, it reached a utilization of 100%. So after I remove the load, will the server return to its initial state and work normally or not? Okay, this is very important. So we use mean time between failures, MTBF. So MTBF is mean time between failures. So what is the amount between each failure and the other? And we use the mean value like we said. We explained earlier what is the mean, because in some times we might have one failure per day, other times we might have one failure each hour. So this is why we measure the mean time between failures.